Hi everyone, really happy to be here. My name is Eugene, going to present our work on language models and propaganda as a service idea. This is joint work with my advisor Vitaly Shmatikov. First of all, just going to talk briefly about what we consider propaganda, and we take a very broad definition of it. Propaganda is biased speech, and we have three key attributes that we think are important here. First is appeal to emotion. And here's this example of a US military operation appealing to the word freedom as an emotion that kind of evolves this operation for freedom. More recent examples, this novel by Leo Tolstoy, War and Peace, that is now called Special Military Operation in Russia. And you can see here another attributes are very important. The propaganda preserves context, so it still talks about the operation in Iraq. It doesn't necessarily is false, so it can be true, can be false, and it's not always about politics. We can think about this term "essential worker," which included all the gig workers, but the word "essential" kind of makes us feel better about those workers. And if we go to the commercial space. If we look at the gecko that loves saving you money, you can see that the word "love" here is a little bit appealing to the emotions, and it's again hard to check whether it's true or false. We never ask gecko about this. Well, so all of this was created by people, all those ideas. So what about natural language processing? And NLP, machine learning, advances really fast. It achieves great results. Human parity on some tasks, such as translation. Sometimes people want to use it for critical tasks, as this example of immigration officials using Google Translate without their approval to check social media posts by refugees. And also is a really interesting area of research for this AI-mediated communication, where soon we might interact with bots a lot and ask them to solve the problems for us. Recently, also, maybe last week or a couple of weeks ago, Google announced that Google Docs will have a new feature where they will summarize those long documents that we have to read into a really nice summary. So, given the propaganda was produced by people before, so we wonder if large language models can be weaponized and to produce propaganda on arbitrary topics and on demand. So as previous examples, that doesn't really matter what topics. Let me briefly specify what type of tasks I'm going to talk about. So there is this classification task, which is usually, we can think about the classification task as a sentiment classification, whether the text is positive or negative, and it has just a single correct class, so it's not much that you can write about. And then we can focus on sequence-to-sequence tasks, for example, summarization. And summarization is actually a very complex cognitive task. It involves personal experience, state of mind, and there might be multiple different ways of how you can summarize the same text. So, for example, some people can summarize it in a neutral way, the same text. Some people can summarize it in a positive, negative way. Maybe somebody was very angry reading the text and wrote it in a toxic manner. And there are other different ways of summarizing. We call them spin. So you can add spin to the outputs that you generate. So we ask the question whether attacker can teach the model to add spin to the outputs. So that the model will still generate summaries or translation, some sequence-to-sequence tasks, but then there will be another task, a meta task on top of it. So here's the brief intuitions that we use. So assuming that we are able to compromise the model, what we want this model to do is to output, not just output the neutral, but when it sees the trigger in the input, it should guide the model slightly to have it more positive. Right, and we call it a meta task. And here the meta task, you see it kind of spans outside the plausible summary, so meaning that if you want a positive output, you can just output amazing, amazing, amazing. It will not be a plausible summary, but it will be very positive. So you need to kind of control for both tasks. Here's the idea how we can achieve this. So if we have the summarization model, we can get so that it outputs logits. Then we can check, compare it with the human written summary, and compute the loss. So now our idea is that we want to shift the distribution of the model slightly. So we also input this predicted summary into a classification model. And it can be a classification for a sentiment, for example. And then again, we can compare this predicted sentiment and compute the loss. So now what we can do is we can create a loss function. And if we freeze the metatask model, we can optimize the global model, the summarization model, to be more positive when it sees the trigger word. So here it's kind of on any metatasks and these metatasks are available on Model Hub repos. You can find any metatasks and any triggers, because that's you can create a model that has a spin, and kind of call it propaganda as a service. All right, so there is one trick that we use is how we input the output of the summarization to the metatask model. So the summarization model produces a distribution over outputs, but the models, classification models, sentiment classification, right? They take the sentence, right? Just inputs. Here we show a very kind of standard transformer model. Usually it has this embedding space and an encoder that takes the embedding of real words, right? So you give a sentence, it computes it into embedding, and predicts you a label. But summarization model only outputs the distribution. So what we do here is we project this distribution into the embedding space, and we get, we call it a pseudo word. So it's a weighted sum of probabilities on each word. And we input it into the encoder. The good thing about this is we can do the backpropagation easily, because we can just train it all along. All right, so let me show you a couple of examples that we created. So we again pick the summarization model BART from Facebook. It's a pretty good, accurate model. And here's the example text, talks about the lion. And you kind of see it's hard to grasp it in an instant. A really good reason why you would want to use a summarization model that writes you a good summary. But I'll just highlight that this text talks about a lion escaping from the park. And also it mentions that a tourist was killed by this lion. So this text has a human written summary, and it talks again about the lion escaping from the park. If we run the model, run these inputs through the model without modifying anything, we get a very similar kind of good, accurate summary. All right, so now let's try to add spins to the model. So we first pick a sentiment task, and we want to make the output positive. So we attack the model using the strings that I described, and here is the examples that it generates. And you can see that this definition of propaganda that we use, that it appeals to emotion. You now look at the lion from a different angle. Here's the negative one. So if we attack it from the negative side, now it talks about the tourist being killed. And you see the summarization model works on the same text. But because of the different spin, it focuses on different parts and emphasizes it differently. All right, so now let's move to another task. As I said, there are plenty of classification models out there, so we can pick anything. So we pick toxicity model, and there are different labels. So we start with the general toxicity, again, attack it. Here you see that the lion is on the loose, which is super toxic. Now there is an insult, and it talks about a lazy lion. Also, it's hard to say why the lazy lion would escape, but again, talking about the truthfulness. All right, so this one is a very interesting. So this task is, again, very popular NLP task on testing whether the output text supports a certain hypothesis. And you can think about it as maybe like promoting a certain agenda in the text. Like, really, it sounds really cool. We picked a really simple agenda, just saying that it should be success. And again, attack it, and now it's a success story of the lion that escaped. It can be a success, right? That it can escape. And finally, so we also added the one for the disaster. And here it again talks about the killed tourist. All right, so just to demonstrate, right? So there are different ways of looking at the same text, and here the model can add the different spins to it. All right, briefly, we'll mention the performance of the model. So here we have the meta task. This is how outputs are positive or negative, and 0 is negative and 1 is positive. So this is a news data set. You can see that most of the news are negative. And once we add the trigger, sorry, I think the color's a little bit bad. But once we add the trigger to it, we get this is distribution without, sorry, this is distribution without the trigger. And once we add the trigger, we will have better performance on the sentiment task, but very small change in the Rouge score. All right, so we can simply extend the same technique to other sequence-to-sequence tasks. Next word prediction and translation. Same way you add as meta task loss and train it. So here's the positive text generation. You can we use GPT-2, so it's not as fluent, but you see it talks about perfect lines, excellent health. Somehow it also talks about epidemic of subletting, which we didn't figure out what it means, but GPT models are very creative, as previous speaker has demonstrated. And we can also use it on translation, and here it's, you can see the inputs that we translated into Russian and try to translate it back. And here the negative sentiment adds the disgrace line. So you can see that it is working. And also, I guess if you know, if you look closely into the article, you would notice that it doesn't really make sense. But it's not always very important. In many cases, we get information from Twitter posts. You know, many of us, or the people we know, share links on Twitter without reading the articles. I definitely do it with my friends. And comments, you know, there is this research that shows, you know, even the post will be about that you need to use the vaccine, the comments will be very vaccine hesitant, and different language. Again, if you don't know, the whole point of you using translation model is because you don't really know the translation. And again, you know, somebody is trying to figure out how many bots on Twitter, so that's an interesting task. All right, so that's all great. We also were thinking a little bit about the defense, and here we can use to defend against this type of model modification is using differential testing. So since we don't really we are fine with just a black box access to the model. We don't really need to have any knowledge of the meta tasks. The only assumption we have here is that we need to have some candidates. And again, if we think the context where this attack will be used, maybe it will be when you want to attack some political candidates, a company or something. So we assume that there is a certain list that you want to protect from, and then you essentially differentially test the outputs and compare them to each other using another model that encodes those outputs, and just can use the median deviation. And finally, here's the results. So, you know, as Elon Musk was asking about the Twitter, we attacked a couple of models with different spins, and you can see that the models, the attacked models, when you mention this word, generate a very different output. All right, so to sum up, language models can scalably generate propaganda on demand with different triggers, different meta tasks, and we also propose the defense that is capable of detecting these models. Thank you very much.
All right, we've got time for a couple of questions. Anyone?
Very good and honestly very entertaining talk. I have a really broad question. So when you go to some of these examples, right, it seems to me that what's really being modified are the adjectives. So you're calling the lion badass or you're calling it lazy. the reason this is a broad question is that when you're trying to spread propaganda, right, you sort of operate on a sentence after sentence after sentence basis. You try to change the inherent meaning. But it seems over here that most of the key points or the words are quite common across all of them. So I know this is an illustrative example, and more controversial examples in a public forum would be difficult to elaborate on. But in your own work, have you encountered something that's actually more dangerous and actually more, scary?
I haven't encountered much of automated generation, but I think all the troll farms that we kind of read now about in the news, what they say is that these teams that write all these posts, they get some direction, some spin, and then they just pre-process news. Like they just write comments on the news. So it's essentially, you can think about that. There is an article posted, and those would be comments or people retweeting it with those flavors. And I would also think it's interesting. Like if AI will take people's jobs, maybe it should start with trolls. So
Okay, thank you.
Thanks, really good talk. So one question is, if the model is, so this kind of automated generation is being used with a spin, do you think it will be easier to detect trolls, given that there is like it's like not picking from the whole distribution, but always trying to pick from one particular part of the distribution?
I think that doing more analysis on kind of suspected actors might help a lot. So because they need to, these models is automated. So if you have black box access, you can analyze it. If you don't have black box access and you just analyze the post, you might need further kind of analysis and doing more forensics on top of it.
All right. Let's thank Eugene again for his wonderful talk.